So good afternoon everyone. So today we're going to talk about the firewalls, module 2 of the end-to-end security program. So this is one of the most important topic with respect to the CCIE security. We're going to start from the very basic of the firewall. What is a firewall? Why we require a firewall in your production? What are the different interfaces on the firewall? High availability on the firewall and different topics. So what is a security domain? Before starting the firewall, we should know what is a security domain. So to start with this, what is a network security engineers does? So network security engineers must protect the valuable resources within a particular network. That's what the main agenda of a network security engineer in a company. For example, a corporate data might be confidential or critical to the operation of a business or to offering a patient care, in which case it must be kept from prying eyes and protected from tampering. So basically we want our critical data to be get protected. But to protect those particular critical data, what we require and from whom we want this particular critical data to be get protected. Let's understand that. To protect these resources, the network must be somehow be divided into two major domains. What are those? One is called as a trusted domain, where I trust the most, and one is the untrusted part of the zone, which is nothing but in our topic will be internet, unsecured zone. The trusted portion of the network are also known as a security domain. Everything inside the security domain is protected from everything outside the security domain, which is your untrusted part. The most common and the effective way to implement a security domain is to place a firewall at the boundary between the trusted and the untrusted part of the network. So basically we require a firewall to make a line in your network between a trusted world and an untrusted world. Firewall overview. Let's talk on that. What is the basic idea behind a particular firewall that we have already discussed? To make a line, to draw a line in your production, in your perimeter level, where we define that these are the devices, these are the resources which are where in very most trusted zone. And this is the boundary from where the untrusted zone starts. So basically there are two goals with respect to the firewall. To provide the people in your organization with access to the www without allowing the entire packet or the world to peek in. And to erect a barrier between an untrusted piece of a software, your organization public web server, and the sensitive information that resides on your private network. Now to explain you this particular point, let me start with a particular slide. Now let's say for example, what is an application? An application can be a software which provides services to the user clients. Now, like the way we have a network world, network which is divided into three tier of hierarchy that we usually call as what? Core, distribution, as well as an access layer. In a very same way, an application is also being divided in the three tier of hierarchy, which we call as web, app, and database. What usually happens is, what is the main goal of a particular firewall? I have a user, let's say for example a Bob is sitting over here. I should have a kind of a device in my production at the perimeter level or at the last boundary of your production, which is going to get connected with the internet. I want to give him that facility that Bob, anytime you want to go out, you are allowed to go out towards an unsecured world. You don't have to take any permission. But whenever any outside person, like Alice is sitting outside over there, or the person or the packet, if it's coming from an unsecured zone, it has to take a permission, because by default this packet should be denied. So if I'll read my line again, to provide the people in your organization to have an access to the internet without allowing the entire world to peek in. So impose a specific configured gateway machine between the outside world and the site inner network. All traffic first go to the gateway where the software decides whether to allow that particular packet or to reject it. Firewall. It's basically a metaphor. If we want to have a precise definition of a particular firewall, so a network firewall is a system. It can be a single device. It can be a single device. It can be a group of devices, and so on and so forth. So when I talk about a firewall, it can be a system, a single device. A firewall can be a single device. A firewall can be a group of systems. That means multiple devices. Why we require multiple devices? Just to have an HA, high availability. A trusted, we require a group of systems used to control access between the two networks, a trusted network as well as an untrusted network, using a pre-configured rules of filters. Firewall can be a hardware or it can be a software also. So when we talk about the firewall, both it comes in an appliance mode also as well as hardware. It comes in a VM form also that can be deployed on your hypervisors. It can be a single router. You can make a router by applying an access list. That router becomes a stateless firewall, which we gonna talk in the future lectures. It can be a multiple routers. It can be a single host. It can be a multiple host running this firewall software. As I mentioned, it comes in a software as well as a hardware. It can be a hardware appliance specifically designed to provide the firewall services or any combination. They vary greatly in the design, functionality, architecture, and the cost. So every different kind of a routers comes with their own variable functionality as well as an architecture. Security levels. Now, what is the major goal of a particular firewall that we have already discussed? The trusted zone, the secured zone, or the devices which is present inside your domain should be allowed to go out, but the devices, but the people who are there in your untrusted network or outside your network should not be allowed to move it. Now, saying this particular line, I'll take this as an example. The topic is the security levels. Now, basically, a security level is nothing but a value which is being defined from 0 to 100. Least is the worst, 100 is the best. So the interface, yes, and the security levels will be defined. Where? On the interfaces. So by this security level, but we define on a particular interface, we'll get to know that whether that particular resources are there in a trusted world or in an untrusted world. Now let's say, for example, I have a firewall, can be a VM, can be a hardware. Now this firewall, which is present at the perimeter level, I'll be having, let's say, for example, two interfaces. Generally, we basically take, and this is the best practice which I'm trying to tell you, gig 0/0 and gig 0/1. Gig 0/0, the last one, O, represents your outside. 0 is usually represented with the outside. That means this is an interface which is going to my untrusted world. This is going towards the WAN. This is going towards the internet where the hackers are present. So by default, the security level will be the least one, 0. That means on this interface, I don't trust at all. In a very same way, this gig 0/1, this is an interface which is going towards my inside zone, inside world, where my network resources will be present over there, which is going to be get connected with the LAN. And under the LAN, you will be having multiple resources in a different subnets, different VLANs, and so on and so forth. So when you say that the interface is an inside interface, that means the security level will be what? 100. That means this interface is the most secure one. And what we say since starting, what is the goal of a particular firewall? The goal of a firewall is to allow the traffic from a trusted zone to an untrusted zone. So can I come to a very important conclusion that traffic flow, when we talk about a traffic flow, that means traffic is always allowed from higher security level to the low security level. But whenever the traffic is coming from a very least untrusted zone, the firewall should drop that particular traffic. So can I come back to another conclusion? Whenever the traffic is coming to a low security level, to a high security level, the traffic will always be blocked. Now to allow this particular traffic, we need to write certain rules. And that rules will be like your access list. One kind of a rules that we can set of a rules. You can perform and save your internal IPs by deploying a NAT over there. Address translation. So these are the basic of the security levels which are usually present over there. So saying this particular thing, if I'll get back to my slide, inside. Now what devices, what resources are there? The one which is present in the most trusted network, a private network. Outside, the public or the untrusted internet. And one more zone we do have, that is called as DMZ zone, a zone containing the servers which are accessible by the public internet. Now how will I explain this particular? A moment ago I said that what is an application? An application is nothing but the services which is being provided, or maybe a software provided to the client for the user interaction with the help of your GUI or user interface. Now I said that an application is basically being divided into three major hierarchy or tiers are there: web, app, as well as DB. Now let's say, for example, a basic example of the Facebook. So the moment you deploy and you try to log in into the facebook.com, always it asks you what? The first page is a login page where you need to define your username and the password. And whenever you are going towards the Facebook, you use mostly the 443 as a port number, HTTPS. Now let's say, for example, I'm having a Facebook as a company. So what I'm going to have, I'll be having a bunch of multiple web servers which are present over there. So this is like my web server present over here. Similarly, I will be having what? App servers will be there, which is going to provide the application, and there will be a database servers also will be present over there. So a firewall should be in that particular place, which is going to have an outside interface. I have already told outside interface always goes with the security level 0, which is connected with what? Your internet, where the users will be present. Let's say, for example, a Bob is present over here, and Bob wants to access that Facebook account. So what is going to happen? It is going to go towards the Facebook web server. But web server will be presented where? In a different zone that we generally say as a demilitarized zone. Now the question comes, when you talk about Nitish, the inside world, inside zone is having the highest security level. Let's say, for example, what? 100. And when you say the outside world, the security level is 0. Then what's the security level for your DMZ? It's a very good question. Do remember that on the firewall, whenever you define a security level, I said that the security level always will be defined where? On the interfaces. It's not a global command. It has to be defined on what? The interfaces itself. Let's say, for example, I said that interface gig 0/0. The best practice always says that gig 0/0 should be given a command name if as what? Outside. I'll give an IP address to that. An IP address, let's say, for example, is 1.1.1.1/24, and I'll give a no shut. In a very same way, I'll write interface gig 0/1 name if as what? Inside. And let's say, for example, I've given an IP address to that particular device is 2.2.2.2/24, and I'll give you no shut. Now your question should be, Nitish, where you have defined the security levels over there. So please make a note of this. Whenever you define the word inside, it can be a small letters, it can be a capital letters, it can be the combination of both. whenever you have defined this word on the particular interface, by default, the security level automatically is going to become 100 over there. You don't have to specify that. Now, the moment you're gonna write any other name, any another name apart from the inside, the default security level automatically comes to be what? 0. Now the question comes, how DMZ is in 0? I said by default you give any other name, then inside that interface security level will become what? 0. So if you want to define a security level for a particular interface in middle of 0 to 100, you can go and write like this: interface gig 0/2 name if is, let's say for example, DMZ. So do remember, DMZ by default security level is 0. If you want to define a security level, you can just write security level and you can write it like, say for example, 50. And then you give an IP address scheme over there, let's say for example 3.3.3.3/24, and you give no shut. So saying this, what we are trying to say, what are the DMZ zones? So whenever the Bob is trying to coming over here towards the Facebook from outside, because it is coming from the lower security level to a higher security level, because web servers are present over there, if the rules are being applied on this interface to do the routing towards the DMZ, then only the traffic will be allowed. Otherwise, by default, what is the by default behavior of a firewall? From your low to high, the traffic is always going to be get dropped. But from high towards your low, the traffic is always allowed over there. So I'll have my first set of rules to secure it by saying that allow from your lowest security level, that is outside, towards the DMZ. So a user will always hit what? The web server. If he gets authenticated over here with help of his username and the password, then he will be moving towards the next field. That means now he can access your application as well as data. But to again access your application and database, because you are again moving from low security to high, how? Because DMZ is in your 50 as well as your database as well as your app servers are present where? In the 100. That means again new set of rules you need to apply so that you can move towards an app server over there. So that's how basically in the production the firewall will be deployed over there. On the basis of what? The zones. On the basis of levels. Now when I'm talking about the security level, this is important to understand. I'm talking with respect to only Cisco devices. It's not the case of Palo Alto. There the things works differently. There the things work on the basis of zones. So saying this particular thing, if I'll go back to my slide, a zone which containing the web servers, and web servers are what? Which are accessible by the public internet. The security level indicates how trusted an interface is compared to another network or interface. Higher, more trusted; lower is the least trusted one. Each interface on the firewall is a security zone by which, using these security levels, we have different trusted level of our security zones, and that's what I said as if now. So over here I have taken the same example. So outside, inside as well as DMZ. So your inside will always be allowed to go outside. Your inside can always go towards your DMZ as well as the web servers. Why? Because they are coming from high to the low. But the traffic coming from low to the high is never will be allowed. That's why we define what the security level. So the important conclusion over here is, when you define DMZ, it doesn't mean that the security level is 50. It could be 60 also. It could be 70. It depends on you how you define the security level and how much you trust that level. Now over here, then the question comes, let's say for example, I have a firewall. Now the question comes, I have a firewall. There could be two different interfaces. Let's say for example, gig 0/1 as well as gig 0/2. They both are going in a different subnet are there. They both are going towards your app servers. There could be a possibility over there. Or maybe here the LAN is there, LAN switch, and then I have my app servers which are present over there, and as well as your database servers are also present over there. Both are in your inside network, both are in your trusted zone. That means here also security level is 100, here also the security level is 100. So as of now, I have said that the traffic from high to low is allowed, from low to high it is denied. Now the question comes is, what about the same security levels? So a very important point that I want to make it, so the traffic between the same security level is denied by default. Can we allow it? Yes, via a certain set of commands, and that we going to talk here is inter and intra side. Inter-interface communication allows the communication between the different interface of the same security level, and the command is same security traffic permit inter-interface. Do remember that? Saying this, there could be a possibility that I have a firewall with its interface, let's say for example gig 1, which is connected over a LAN, which is going towards a server on top of which multiple VMs are there. Now these two, both the VMs are, let's say for example, in different subnets, and I said gateway will be defined where? On the firewalls. Now the traffic is coming over here, hits your interface gig 0/1, which is the highest over there, which is having a security level as what, 100, and the traffic needs to go back on the same interface, and that particular movement, the traffic will not be allowed until unless you give a specific command, same security traffic permit intra-interface. So intra-interface permits the flow of the traffic that comes in on an interface and routed back on the same interfaces. This is the most used example case where we talk about the VPNs, where the hairpinning will be allowed. And we're going to talk this again in the VPN lectures. What is a hairpinning, and so on and so forth. So saying this particular thing, let's move to the next topic and talk about what are the different types of firewalls we do have. The basic one is what? The packet filters, or the story starts from where? The stateless firewall. Now before starting this, I just want to tell you one thing, and just as I'm going to ask you over here itself, what's the basic difference between a router and a firewall? I'm just going to talk on a generic way. By default, a router is always a router because every port of a router is there in what? In a different subnet. And by default, routers allows everything if the routing has been done. So to deny the traffic, we add the access list, a set of rules. Let's talk about a firewall. The firewall also is a kind of a router because every port of his firewall will be in a different subnet, unlike, so firewall basically, this I'm just going to tell you in a basic, what runs in a two modes, in a routed mode as well as a transparent mode. What are these two? We're going to talk in the future lectures. Routed modes means firewall, all the interfaces will be in a different subnet, like a router. That means each interface of a firewall will be in a different broadcast domain. When we talk about a transparent, it doesn't require an IP. It's like a switch in between. It's act as a layer 2 over there. So right now, I'm talking with respect to the router. By default, firewall denies everything from lower security level to a high security level. This is the basic difference between a router and a firewall. To allow the traffic, we add the access list over there. So the concept of the firewall came later, but we do have routers running in the production for many, or maybe a decade or 2 decades ago. At that particular moment, when we have to block certain kind of a traffic, we used to write one access list. And that type of a firewalling on the routers, when we do, is called as what? Stateless packet filtering. So do remember that whenever we talk about an ACL on the routers, we are saying that it's a stateless packet filtering that we are doing that. Now, why the term is used as a stateless? I'll give you an answer on this in a few minutes. So let's talk about packet filters. A packet filtering firewall does exactly what its name implies. It filters the individual packets. They are stateless in nature because they do not have the concept of state table or the connection table. Now, what is the state table and the connection table? Let's understand one more thing. So this is one of the difference that I've told you between your router as well as the firewall. Now, before moving further ahead, if I just let you know one more thing, what is a flow? A flow is nothing but a secure, I'll not say secure, it's a communication between the two devices in which the multiple packets are moving from point A to point B or from source towards the destination. Whenever a packet is moving, not a packet, a connection is being made between a source A and source B, it gives an ID, and that ID is called as a flow ID also. Every flow consists of a multiple packets over there. So whenever the traffic is being started from Bob to, let's say for example, towards the Alice, between these two devices, they are trying to communicate continuously. That means millions of packets are moving between Bob and Alice. Every time, every single packet will be captured and gonna be monitored as well as will be passed through the ACL. So the flow consists of millions of packets. Every time a router where the access list is being deployed is going to analyze every particular packet. Is it good or bad? So the answer is, if every packet of a flow, because the source IP, destination IP will be the same, source port, destination port will be the same, everything is the same. So what we can do is, if every packet is getting inspected by the router, the CPU utilization goes tremendously very high over there. Unlike in firewall. In a firewall, if I have a flow, if the connection has been built in between the sources, only the first packet of the flow will be inspected by the ACL. Remaining all the particular packets will be allowed and will not be subjected towards an ACL. That's how the CPU utilization of a firewall remains calm and constant. Apart from that, they are stateless in nature. Which one? The router with an access list, because they do not have the concept of state and the table or the connection table. To justify this, let's say for example, what's the difference between a hub and a switch? Why switch is much more intelligent than hub? Because every time hub receives a packet, it does what? The broadcast. Why? Because it doesn't learn the MAC address. What's a basic funda of a switch? What is the basic fundamental concept of a switch? That means for the first time it is going to do the broadcast to learn the MAC address. Once it's been done, it is going to remember it's in CAM table. A switch all the time, every time, never does the broadcast until unless it doesn't know that particular MAC address. Switch learns the MAC address. Switch learns the MAC address for a respective amount of time, let's say for example for 300 seconds. Now question comes, how many MAC addresses can be learned by a switch? It depends from the model to model. Now saying this only, let's talk about a router is a stateless firewall. A firewall, ASA firewall, which we're going to talk about, Cisco, are a stateful firewalls. So what's the difference between a stateless and a stateful? Stateful builds a table which we called a connection table, where the data will be saved about a connection. But this connection table is only with respect to the TCP as well as UDP. It nothing to do with respect to the ICMP. No, no, no. It will not work with ICMP protocol. Now, saying this particular thing, how many connections table or particular, how many entries can be there in a particular firewall? So answer is still depend on, it depends from the device to device. The high-end firewalls would have more connection table entries according to the licenses also that we're going to talk about it. So if I'll come back to my slide and let's talk about, they are the stateless because they don't build any table. They don't remember the things. Now when I say that they don't remember the things, they don't build the table, question comes, what are the things which is there in that particular table? Let's say for example, the way switch learns a MAC address, there will be an interface, VLAN, MAC ID, dynamic or static, and what will be the aging timer over there. In a very same way, what are the different fields of a connection table? So that we're going to talk when we'll start with the stateful firewall. A stateless firewall or packet filter is the simplest type of a firewall because it is based on the content of the packet and make decision for permit and deny with respect to what ACLs. The common options included in the stateless packet filtering are source destination IP, source destination port, protocol information like TCP, UDP, ICMP, OSPF, transport layer protocols. Transport layer is ICMP, its types and it goes like ICMP echo, ICMP echo reply, echo request, and so on and so forth. Basically, your packet filtering will be done and implemented on Cisco iOS routers and switches as an access list over there. A packet filtering firewall is often called as a network layer firewall because the filtering is primarily done at the network or the transport layer on the basis of the source IP, destination IP, or if it's on the source port as well as destination port or on the protocol number or the ID. You use the packet filters to instruct a firewall to drop the traffic that meets certain criteria on top of that. What are the strengths of the packet filtering? Packet filtering is typically faster than other packet screening methods because packet filtering is done at what? The lower level of the OSI layer model. The time it takes to process the packet is much quicker. Packet filtering firewalls can be implemented transparently. They typically require no additional configuration for the client. You don't have to do any configuration with respect to the client. It's all need to be done on the routers. Packet filtering firewalls are typically less expensive. What are the weaknesses? This is important. If the ports are open, if I've opened the port number 443, that means all and every one individual can come with that particular port number. So if the port are open, they are open for all traffic passing through the port, which leaves a security hole in your network. Defining the rules and the filters on a packet filtering firewall can be a complex task. How many times you are going to write an access list on your router? If you have 10,000 subnets are there, right? So how are you going to define them? You're not supposed to write that much number of access list over there. Hard to test the filtering rules. Throughput of a router decreases as the number of filter increases. Obviously, if your rule matches at 1000 line, it is going to take 999 times to reach that particular filter. It is going to take the the throughput. CPU utilization goes high like anything. And if you remember, I can spoof my IP and I can get back into your network by changing MAC address, by changing the IP address over there. So that's why we have a new type of a firewall that we're going to talk about is called a stateful firewall. But how we deploy the packet filtering? Normally on a particular router with respect to what your access list. And in which you're going to define your permit and the deny statement because by default it's implicit deny at the back. Now let's talk about stateful firewall. What is a stateful firewall? It does a stateful inspection. It is also called as what? The dynamic packet filtering. Monitors the connection state, and that's very important when it comes to the preventing the TCP based attacks over there. Operates at layer 3, layer 4, and will not monitor the state of the TCP connection, but will not only monitor but also the sequence number. Basically, in a firewall, the inside connections are allowed to communicate the outside, but the vice versa is not allowed. That's where the stateful inspection comes very handy. So basically, in a firewall, the inside connections are allowed to communicate with the outside world, but the vice versa is not allowed. So how the firewall manages this then? This is what the firewall makes and what is called as a stateful inspection. This method can make decision based on one or the more following: source IP, destination IP, protocol type, source port, destination port, and the connection table. Let's understand this particular thing also. Now, how it works over here is, I have a firewall, I have a client over here, and I have a server over here. On the ASA firewall, client is present inside and server is present outside. I said that since starting, this is inside, that means the security level is 100, inside, and the security level is 0, which is outside. Traffic from high security level to the low security level is always allowed. It always allowed. But the traffic coming from low security level to the high security level is always denied. So let's talk about TCP. This client wants to build a TCP connection with a particular server, and we know that the client always has to approach towards what? The server. We know there is a three-way handshake. In a TCP three-way handshake, what we are having? SYN, which always goes with its initial sequence number. We have what? SYN plus ACK, which is what comes with the acknowledgement number, which is, let's say for example, the initial sequence number is 24. So the acknowledgement that we are going to get is 25, 24 plus 1, as well as the server's initial sequence number. And then we have acknowledgement, which is nothing but the acknowledgement ID will come over there. Let's say for example, ISN that has been sent by the server is 64. So the acknowledgement will be what? 65 over there. Now what basically happens? From client towards the server, because coming from high to low, the SYN packet is allowed. But the return traffic, which is your SYN ACK, because coming from lower to higher, is going to be get dropped. So for that reason, the firewalls are nowadays built as stateful firewall, so that a firewall will get little bit of intelligence that the traffic has initiated from inside, and it is just the response packet which is coming from the server, so let him allow. But how this happens? Because the firewall maintains and checks and store these informations. Let's talk about that. In this respective figure, you can see that I have a client who has sent a request towards the server which is present over here as an H1. Now what is the sequence number? There will be a sequence. So what does the packet look like? Source IP is what? Client. Destination IP is your H1 server. L4, this is your layer 4 at what protocol we are using? It's a TCP. Source port, destination port, TCP flag, which is your SYN flag. It goes with the initial sequence number, let's say for example N1, and doesn't have any acknowledgement bit. So you can see that the firewall, the moment this particular packet is traversing, builds a table, and that table is called as connections table, state table, in which it pointed out and stored what? The source IP, source port, destination IP, what protocol, flag, and initial sequence number. While the return packet, when it is going to come from the server, it checks the sequence number. If it's coming with N2, which is nothing but incremental of what? Let's say for example, this N1 is nothing but 24. If it's coming with 25, it checks all the parameters over here. He sees that, okay, the traffic has been initiated from the inside world. Let me allow it without doing any inspection, without needing of any access list to be defined over there. And this makes what a particular firewall as a stateful firewall. How it looks on the firewalls over there, you can see it over here. Show connection protocol with respect to TCP. You can write show connection details also, or just show connection. The traffic is a TCP wall. Outside interface is this outside interface IP. This is your port number of the outside interface. Not outside interface, the traffic, the device which is connected on the outside interface. This is the interface IP which is connected on the inside world. Its port number. It is idle for this many seconds, and these are the flags. Now what these flags represent, this is also very important to understand. Let's understand them. So these are the flags. So whenever the traffic, let's say for example, this is my client and this is the server, if from inside the outside the traffic has been gone as like a SYN packet. So the moment the firewall is going to build a connection table, it is going to build a flag named as SA8. That means right now from this firewall, from inside to outside, the traffic has been initiated, and this is only being sent what? SYN packet. If the acknowledgement is also coming from the server, that means the second round which is going, at that particular moment, it is going to have what? Acknowledgement. It just says A over there. And when the acknowledgement has been sent by the client towards the server, it will show over there as just U. And when actually the outbound traffic, when the client actually started getting traffic and started doing the communication with the server, it shows UIO. Now over here, coming back to here, if you again analyze this connection protocol detail over here, you can see that there is one data which is showing as SAA. That means between this IP and this IP on the respective port number, just the SYN packet, only the SYN packet has been sent. And you can see over here, there is a UIO basically. That means these two IPs are basically three-way handshake has been done and data has been now started getting transferred. So looking at to the flag itself, you can check what are different types of things are getting over it. Now in this particular example, if you see on the right side, if the traffic is being initiated from outside interface towards the inside from the firewall, by default, from lower security level to a high security level, the traffic is always what? Denied. But to allow that particular traffic, you have to write what? An access list. After writing the access list, let's say for example, the client is present now on the outside world with a zero trusted world, and your server is present over here in the most secure planet of your, in the most secure place of your particular production. If the client is sending a SYN, it checks the access list. If it's being allowed, it will reach to what? The server. That particular moment, the SYN will be denoted as B, ASAB. So do remember, whenever in the connection table, if you just see SAA, that means the traffic has been initiated from high security level to the low security level. If along with this, if the B is coming at the back of everything, that means the traffic has been initiated from lower security to the higher security over there. And this is being allowed. Why? Because the access list has been defined over there. So in the connection table, if you see ever the B, that means the traffic has been initiated from the outside world. And the B represents itself, these are the naming convention, you can see that, and B itself represents what? Initial sync from what? The outside world. Now let's move further ahead, and we're going to talk about certain devices in the next lecture. I hope you enjoyed and you got an idea, basic idea about the firewall. Thank you very much.